Hi everyone, in this video we're going to go through 5C, so factorising monic quadratic trinomials. Such a long and complicated heading for 5C. Basically it just means we're factorising quadratics where the coefficient of x squared is 1. So if we just have a quick look at, just get my highlighter up, question 2, all the coefficients of x squared are 1. All right, it's always going to be 1. In question 3, we do have a coefficient that isn't 1, but then we would take out a common factor and then it would be 1. So what we're doing in 5C is only factorising monic quadratic. So the word monic just means 1, okay? And then in 5D, we're going to be doing non-monic. So your coefficient of x squared is something other than 1. Now, when you're doing factorising, monic quadratics, you basically need to follow this rule here in the second dot point of our key ideas. So if we've got a quadratic of this form, x squared plus bx plus c, basically what we need to find are two numbers that multiply to give c, the constant term, and add to give the coefficient of x, which is the value of b. All right, so basically you're looking for factors of c, and then you're deciding which ones add to give you b. So when we start doing these, you'll actually pick it up quite quickly. It isn't really that difficult to factorize monic quadratic. Non-monic, it is a little bit harder. So you can't apply the same theory to non-monic quadratics, but which is what is great about mathematics in general, is often there's more than one way to do things. So with non-monic quadratics, what I always use is the quadratic formula. So we're not going to cover that when we do 5D, but we will at a later stage, and it's just a much easier way of solving quadratic equations. So I will always, if I can't quickly factorize it, I don't try to do it, I just go straight to the quadratic formula. And that'll make more sense when we do 5D, because 5D is a lot more complicated. Anyway, let's move on to 5C. All right, before we start, I'm just going to show you a quadratic. I'm going to expand a quadratic. So let's say we've got x plus 3 and x plus 5. So we know we expand it by doing FOIL. So first, outside, inside, last. So we end up with x squared plus 5x plus 3x plus 15. Actually, I'm going to get rid of that 15 and I'm going to rewrite 3 times 5. So effectively, what we've got in the middle here is our x term. So in this case, it's going to be 8x. And what we've got here is our constant, which is 15. All right, and then we've got x squared here. But when we're factorising monic quadratics, we don't really need to take any notice of the x squared. All right, so you can see that the 5 and the 3 add to give you 8, and the 5 and the 3 multiply to give you 15. So when we're working backwards, so let's say what I've got on this line here, the x squared plus 8x plus 15, we have to factorize, we have to go back. So what I have to say is, all right, I need two numbers that multiply to give me 15. So we can have 1 and 15. That gives you 15. We can have 5 and 3. That gives you 15. And no other factor pairs. So we're only looking at integers, so whole numbers. And obviously you can have negatives as well. So because it is positive 15, they would both have to be negative. But because I'm dealing with positive 8, I know that my numbers have to be positive. All right, so then I say, well, which ones add to give me 8? So 1 plus 15 is 16, and 5 plus 3 equals 8. So the two numbers that I'm using to factorize are 5 and 3. So I write, all right, x plus 5, x plus 3. And obviously you can have that around the other way as well, right? Because you're multiplying, and multiplying order doesn't matter. Okay, so I've just shown you there, we've expanded. So remember, expanding and factorizing are the opposite of each other. So I've expanded this quadratic expression, shown you how we got the 8 and the 15, and then we went backwards and factorized it. So that's what we're going to be doing in section 5C. All right, so 5C. Let's have a look at some from question 2. So start off with A. Okay, so we need two numbers that multiply to give us 6 and add to give us 7. Now, it's always a good idea to find your factor pairs first, because obviously you can have many different combinations that add to give you 7. So it's easier to do your factor pairs. So we can have 6 times 1, we can have 3 times 2, and that's it. All right, that's it, all we need. So that's equal to 6, and that is also equal to 6. And let's add them together. All right, so 3 plus 2 is 5, and 6 plus 1 is 7. So the factor pair we want, the pair of numbers we want is 6 and 1. Now, how I've listed them, you wouldn't really do that all the time, all right? What we can do here is do it quite quickly because there's only 2 pairs of factors for 6. But let's say you had something like, let me just see if there's one where we've got quite a few factor pairs. I might do Q. So we've got x squared. Actually, I might not do Q yet. Let me come back to Q because Q is a special one with their negatives. Let me do F. So x squared plus 11x plus 18. All right, so we need factor pairs of 18. So we've got obviously 1 and 18. That gives you 18. But what does that add to? Adds to 19, and we want 11. So another factor pair is supposed to multiply. Another factor pair is 2 and 9. That gives you 18. And when we add it together, we get 11. I could have done another one, so we know that 3 times 6 also equals 18, but when we add them together, we get 9. So you don't have to go through and test every one, and eventually you'll just do it in your head, okay? So you wouldn't write all this. It's very time consuming, and if it can be easily factorized, then you can easily do it in your head. So you're just thinking of two numbers that multiply to give you 18, and add to give you 11. And there they are, 2 and 9. All right, so before I was about to do a negative one with a negative in it, so I'm going to do J first of all. Now, negative numbers, there's really no difference, but you do need to consider that your factor pair, either both numbers are negative or one is negative. All right, so we're looking for a pair of factors for negative 4. So I've got negative 1 times 4 gives me negative 4, but also 1 times negative 4 also gives me negative 4. You could have 2 and 2, but I know because I've got the 3 here as a coefficient of x that it's highly likely going to be 1 and 4, but is the 1 negative or is the 4 negative? So this is what you need to do in your head, but let's just write it down. So 1 plus 4 is positive 3. If we had 1 plus negative 4, we've got negative 3. So our factor pair, sorry, I shouldn't keep saying factor pair, our pair of numbers is negative 1 and 4. So x minus 1, x plus 4. All right, let's do another one. I want to do, now Q I was doing before. Okay, Q is an interesting one as well. X squared minus 9x plus 18. Okay, so again, we're going to have lots of factor pairs with 18. So I know it's not going to be 1 and 18, so I'm not going to bother with that. And I know it's also not going to be 9 and 2, only because that's not going to add to give me 9 or negative 9. So it's going to be 6 and 3. So 6 times 3 gives me 18. But it has to be positive 18, but when I add 6 and 3 together, I get positive 9, but I want negative 9. So that means that your 6 and 3 are both negatives, because a negative times a negative gives you a positive. And then we've got negative 6 plus negative 9. Oops, not negative 9. Sorry, I'm writing the answer there. Negative 3 equals negative 9. So your pair of numbers, negative 6 and negative 9. Now you're probably wondering why I wrote plus and negative. Just so we could see that it was a negative 3, I guess. There's nothing wrong with writing plus and negative 3. If I was to go on, like this is my side working, I would actually write negative 3, but I wanted you to see that the two numbers are negative 6 and negative 3. All right, let's go on and do some harder ones. So having a look now at question 3. So I'm going to pick a hard one from question 3. Let's do K, only because I'm assuming the very last question is usually the hardest. So I've got negative 5x squared minus 20x minus 15. All right, so when you're factorizing quadratics, the first thing you should do is say, well, can I take out a common factor, especially if it looks like a non-monic. So you can see here the coefficient of x squared is negative 5. You want it to be, if you want it to be a monic, obviously it needs to be 1. So for this one here, to make it 1, I need to take out negative 5 as a common factor. And it's good because negative 5 actually goes into negative 20 and negative 15. So then we're left with x squared plus 4x plus 3. Now just do a quick check, especially if you're a little bit apprehensive with your negatives. So negative 5 times x squared, negative 5x squared, awesome. Negative 5 times 4, negative 20x, negative 5 times 3, negative 15, awesome. So we need now two numbers that multiply to give you 3 and add to give you the 4. So it's good there's only one factor pair of 3, which is 3 times 1. And then obviously when we add them together, we get 4. So that negative 5 stays out the front, but now we have factorized the x squared plus 4x plus 3. So it's x plus 3, x plus 1. All right, let's move on to question 4. So you should be doing all these questions. All right, so it's extremely important that you can factorize because it's a key skill in methods and it's assumed knowledge, and you need to do it without your calculator, even though you can quite easily do it on your calculator. All right, so 4a, we've got x squared minus 4x plus 4. Now, remember in a previous video, in probably 5b, we did perfect squares. So if I scroll up, I've kept all my working here. Let's just see. That's not what I wanted. I wanted the other one. Where did I put it? Oh, I've gone too far. So there's 5b. There's the difference of perfect squares. Pretty sure I did the other one. Oh. I'll just write it again. Okay. Don't know why it's not there. Okay, so if we've got a perfect square, that just means, and I'll do this on the side, that you've got x plus something, so let's call it x plus 2 squared. So when we expand that, we're going to have x squared plus 4x plus 4. All right, so basically in general terms, let me just get rid of actually all of that. If we had a plus b squared, we're going to have a squared plus 2ab plus b squared. Now, I'm pretty confident I covered that in a previous video, even though I've done these videos twice, because the first time I did it without the microphone on. So, yep, this is the second time I'm doing this video, and I did all the other videos twice as well. Okay, so that's what it means by a perfect square. The a plus b, or whatever the bracket is just being multiplied by itself. So you can see here, we'd still factorize it the same way. All right, because it's told us it's a perfect square, we know that the two numbers have to be the same. So I know that it's not going to be 4 times the 1 because they're not the same number. So it can only be 2 and 2. Now, you'll notice with this one that we've got a negative number as a coefficient. So that means these have to be negative. So when we're factorizing this, we're going to have x minus 2. Effectively, we've got x minus 2 times x minus 2, but remember, we write that as x minus 2 squared. All right, so that's what it means by a perfect square. All right, let's do another one. All right, where am I? Question 4. Let's do J. So we've got negative 3x squared plus 36x minus 108. All right, and I remember doing this question in the previous video too. So again, we take out a common factor. Now, I know we're in 5C, so we're doing monic quadratic. So I know that negative 3 is going to be a factor of 36 and 108. Now, if it wasn't, that's when we solve it using non-monic. We treat it as a non-monic quadratic, which we're going to do in 5D. All right, so taking out the negative 3 as a common factor. All right, so remember, a negative times a negative gives you a positive. That's why we've got negative 12x there. And then we've got 108. Now, if you can't divide 108 by 3 quickly in your head, just do it off on the side like this. How many times does 3 go into 1? 0. How many times does 3 go into 10? 3. Remainder 1. How many times does 3 go into 18? 6. No remainder, so it's 36. All right, we can just do it quickly on the side. All right, so now we need two numbers that multiply to give us 36. Now, the question did say it's going to be a perfect square, so the square root of 36 is 6. So that means 6 times 6 is 36. But again, I've got this issue of a negative coefficient, which makes it negative 6 times negative 6. So I'm going to have negative 3 times x minus 6 squared. All right, let's move on because there's some tricky ones coming up. All right. Question 5 and 6. Now we're dealing with a quadratic expression on the top and on the bottom. So what you should always do is factorize and then see where you can cancel. Now, I've seen some students in Year 10 do this. So let me just write this expression, the first one, x minus 9. So they go ahead and say, oh, that x cancels out with that x, and 9 goes into 54 6 times, so I'll put a 6 there. You can't do that sort of cancelling because what this fraction actually is, let me just get rid of them. Oops, got rid of the 5. Let me just put the 5 back. All right, each term on your numerator is over that denominator. All right, it's x squared over x minus 9 minus 3x over x minus 9 minus 54 over x minus 9. All right, you can't cancel when you have separate terms, and effectively you've got separate terms here. You can only do cancelling when you're multiplying. All right, so if we had 2x over x, 2 times x, so that can cancel. But if we had 2 plus x over x, we can't cancel that, okay, because there's 2 separate terms there. All right, so please remember when you're cancelling to not make that error. All right, let's move on to this question. So the whole purpose of 5a and probably, sorry, not 5a, question 5 and question 6 is to look at where you can cancel. So factorize to cancel basically. So cancelling just simplifies things for us. All right, minus 3x minus 54 over x minus 9. Now, if you thought about it, they've written these textbook questions to clearly have what I've just put in brackets, that to cancel. All right, to me that's like, oh, I'm probably going to see an x minus 9 on the top. It's not always going to be the case, but you're just learning about quadratics. So I can probably safely say that whatever is on the bottom or on the top in the case of D, E, and F is what you're going to be cancelling. All right, so let's just see if it's true. So let's factorize x squared minus 3x minus 54. So we need two numbers that multiply to give, negative 54 and add to give negative 3. So what I usually do if I'm factorizing a quadratic, I set up my brackets and put my x's in, or whatever letter you're using, and then I've got space to put it in. Now I've got a negative 54, so that means one of them has to be a negative and the other one is a positive, because a negative times a positive gives you a negative number. Now the difference between them is negative 3, so that must mean the larger number is my negative and the smaller number is my positive. So as I said before, we're going to have them cancel out. So x plus 6 is your answer. All right, let's do one more before we move on to question 6. Let's do 5F. So again, I reckon something's going to cancel out with that x plus 1. Okay, let's get our pens ready. So x plus 1. All right, on the bottom, do your brackets, put your x's in. All right, we've got a negative 6. Obviously, one's going to be positive and one's going to be negative. I said that around the other way. And we've got negative 5. So your bigger number is going to be the negative. So I can see that's going to be 6 and 1. All right, so I've done so many quadratics in my time that you can quickly identify them. And when you get to year 12, you'll do it quickly too. All right, so that x plus 1 cancels that with that x plus 1. Now that does not mean, so not equal to 0 over x minus 6. All right, cancelling them out is basically, it means they equal 1. All right, so if you've got the same number on your numerator as your denominator, you know that's equal to 1. So x plus 1 over x plus 1 is equal to 1. So what that becomes is 1 over x minus 6. Now, if you're wondering, oh, but in the previous one, you didn't have a 1. Previous question, you didn't have a 1. Well, you can put it there if you want, over 1, but we don't tend to write numbers like that, do we? Okay, I'm just going to rub that out so it doesn't confuse us if anyone's looking at our notes. All right, let's move on to question 6. Now, I was just thinking, if I'm doing a question and I've just noticed I'm talking quite quickly, if you get to the end and you're like, oh, don't really understand that, go and listen to it again, all right? And really do it step by step and try to take in what I'm saying, okay? Because I know I do talk quickly, so you can pause it. I know some people probably listen to me on 1.5 speed as well, so maybe go back and listen to me on normal speed. Yeah, okay. This one I'm thinking I might not have enough space to do it here, so I'm going to go on to the next page. And again, you should be doing every single question. I know I'm not, but we don't want these videos to really go forever. All right, x squared minus x minus 6 over x squared plus x minus 12 times x squared plus 5x plus 4 over x squared minus 1. All right, so it's a little bit different to the previous one because we've got basically 4 quadratics that we've got to simplify or factorize. So I'm going to just do one at a time. All right, so basically going 1, 2, 3, and 4. Okay, so we're going to factorize all of them. Just keep them in the same spot, but have them in their factorized form. All right, so the first one, we need 2 numbers that multiply to give us -6 and add to give -1. So that is a -1. All right, so we're going to have, one's going to be negative, one's going to be positive because I've got that -6 there. And because it's a -1, my 6 is going to be the negative and the 1 is going to be a positive. I just had a bit of a, hold on. Just had to rethink that. No, what am I doing? Actually, I think when I did this question in the video that didn't work, I did the same mistake. Oh my gosh. -3 and 2. I did exactly the same error in the other video. All right, I think because I saw the 1 and the 6 and just got a bit distracted. Okay, so it is -3 and 2. Let's do the next one. So we've got -12 and 1. So again, one of your numbers is going to be positive and the other one's going to be negative or negative and positive. So 3 and 4. Now, because you got +1 here, the 4 is going to be the bigger number. All right, and let's do this one over here. Okay, so it's going to be 4 and 1. And then x squared minus 1. So we've got the difference of perfect squares there. So remember that is x plus 1, x minus 1. All right. What am I doing? All right, so cancelling out. So you can only cancel something that is on the top with something that is on the bottom. And because you're multiplying, basically you can just get rid of that multiply sign and bring that vinculum all the way over. Okay, so that's the same thing. So we're multiplying the top and multiplying the bottom. But because we're multiplying everything, we can cancel. Okay, so what's inside the bracket I know is not being multiplied, but the brackets themselves are being multiplied, so we can cancel them out. So this x minus 3 cancels with this x minus 3. This x plus 4 cancels with this x plus 4. And this x plus 1 cancels with this x plus 1. So what we're left with is x plus 2 on the top and x minus 1 on the bottom. All right, we might leave that video there. So question 6 can be quite challenging, but I think very rewarding. And by the time you get to question 6, you'll probably gain a lot more confidence and you'll be able to cancel them like I've done with 6G. All right, guys, bye.